Hey, welcome back to BarryT's Garage, and I'm BarryT, and today we're doing something a little different. I got Steve Coppock with me. Hey, Steve.
Hey,
Good.
Barry, welcome back.
Thank you. We've done a number of videos on Ford Flatheads, and it's not the only thing you know about, but it's the thing we tend to talk about
Yeah,
here. And we've collected a bunch of questions that have collected where people have questions, follow up on the video, different things about these flatheads, and a lot of times the setup with the supercharger kit you have. So this is an opportunity to answer some of your questions, and thank you for those comments and questions. It's really cool. Steve, we're going to see. I didn't share these questions with Steve ahead. He hasn't looked through all this, so we'll see how he does.
yeah, thanks. And yeah, Barry, I'll do my best, right? I because of that, I really haven't prepared answers, so I'll give the answer best I know, and if I don't know, I'll say. And
Yeah,
I'm also happy to come back and follow up on a question I don't know of at a later time.
sure. Fair enough. This is all fun.
Yeah,
We're
yeah,
hanging
no, it's
out.
good.
It's all good.
Okay.
All right. Well, let's see where we stop. The first question comes up under engine sealing. Not that cars ever have oil leaks or anything like that. So let's see. Have you had any experience with installing rope seals on these flathead V8s? And do you have any tips for people that are struggling?
That is a really great question. And yes, in fact, this engine right behind me here has a rope seal in the back. Uh, Standard, it would have a rope seal in the front and the timing cover and oil pan as well. But I put a more modern one-piece seal in the front of this motor.
Okay.
So it's a round rubber neoprene or rubber seal, I guess.
Mm-hmm.
But in the back, definitely a rope seal. They've come a long way. The rope seals actually work pretty good. But I'm sure whoever's asking this question has fought with them, both installing them and maybe not been successful in getting them to seal up.
Yeah.
And I guess just know that these are, you know, 70, 80, 90-year-old technology, and sometimes they do leak a little bit. But with that said, they make some graphite-based seals, and maybe here in a minute I'll grab one because I think I have one right over here.
Okay.
But way easier to install than the traditional rope seals.
Oh.
Just the other day, and somebody might want to look this up, but I think Mike Herman at H&H Flathead did a video on installing a graphite seal. I saw it just this weekend, I think. And the technique they use is exactly the technique that I've learned to use. But basically, the graphite seals, you don't really have to soak them in oil or anything. You just lay them in the groove and push in the best you can with your fingers.
Okay.
And then you take I don't know, about a 3/4 inch, 7/8 inch socket, like a deep well socket, and put it on its side and use it to roll that graphite seal into the groove and
almost like a rolling pin, huh?
Yeah, exactly, and press it in, and it'll almost press all the way in that way. Then there's a little bit that sticks up of the seal above the block or the oil pan in this case. And most of the suppliers of those seals have a little, it's like a cardboard shim that you put on top of the block, and take a knife and you just cut the excess off, and you're left with maybe, I don't know, 20 thousandths sticking up above the surface. And then when you bolt everything together, it presses those together. And I would say they work just about perfect every time.
Okay.
But yeah, maybe we can find a link to that video and post it to this session so people can see that done.
Okay. And you think you have one around somewhere here?
I'm pretty sure I have one right over here. So, like we were talking, Barry, this is an example of this graphite rope seal. And graphite's used in a lot of applications because it's relatively smooth. It's low friction, so that makes it good for these seals. And you can pack them, form them very tightly so they don't typically leak through. And you can see they're square. The rope seals are typically cylindrical shaped, so they fit right down in the groove where the rope seals would go really, really well. And then, as I mentioned, once you get it in, there'll be a little bit sticking up above the block, and use a little template and trim the excess off.
Okay.
I also this is a front seal. I mentioned the aftermarket makes a one-piece seal for the front of the flatheads. So this sleeve is smooth. The Ford version of this is got grooves cut in it, so as the crank turns, it tends to push the oil back towards the engine that get into the grooves. But since we're putting it on a one-piece seal, it's smooth. But this goes onto the crankshaft, and then this seal slides on like that.
Yep.
And then you fit the timing cover, So the lower part would fit into where the rope seal would go, and then when you put the oil pan, it's also cupped and fits right over the top. And usually I put a little bit of sealant, RTV kind of sealant. I use ultra gray. That's just my
Your favorite?
preference, but there's plenty of other good ones. And put that on the outside, and it seals up nice and tight.
Okay.
And this one, we've had it on the dyno test, and there's not a drop of oil on the front or the back. The back has the graphite, the new graphite, and the front has the one piece, and it seals up just fine.
Perfect. Okay.
All right.
Well, is there anything that could happen with maybe the used block that you're working with? Is there any defects that could come up in it you might not notice that would make it more difficult?
I don't think so. I think like you would with any part of the block, you're always going to do a visual inspection of the block. But any rust or corrosion that would be in the area where these seals have to ride, or the surface of the crankshaft in the back, or these sleeves, they need to be free of
smooth,
clean, free of corrosion. Any debris needs to be cleaned out. But I think most people rebuild an engine would know what to look for, just cleanliness and uniform surfaces, so that a good seal is possible.
They're thinking about windage of the crankshaft. Okay, so that's the context, windage. And this person's asking, can you apply vacuum to a crankcase to eliminate windage effects in an engine, flathead engine?
Well, this is one I don't know the answer to, but I'll give you my opinion. Is to an extent, yes. The vacuum, what you're trying to do there is get the air out of the crankcase, or any combustion gases that happen to make it past the rings. And there are benefits to operating the crankcase under vacuum. I'm not sure though how much of that is related to windage or other factors. I'm just not. That's just not my area of expertise.
Okay. It's a possibility. We'll leave it at that.
Yeah, well, certainly race engines typically use some type of vacuum system to draw a vacuum on the crankcase, and there are benefits. I just am not sure how that applies to the flatheads. Probably does to some extent. Probably less than a NASCAR engine or top fuel dragster or something like that. I don't really know the answer.
Okay, fair enough. All right, next question. Do you have a blower for a flathead 218 straight 6 from a 48 Plymouth? What can happen with your kits? Do they work on other things?
Well, let me say this about that. The superchargers are universal. Those superchargers aren't built for flatheads or really any engine. They're just built. And they can be adapted to any engine, really. There's some things to think about when you're selecting the supercharger that you're going to adapt, like the size of the supercharger. Typically, this is a ballpark thing to think about, but typically the displacement of the supercharger, and so this one here is called a 174. That's because it displaces 174 cubic inches of air with each revolution. This engine, if you remember, is about 289, 290 cubic inches. So a rule of thumb is a supercharger that's about half the displacement of the engine. That's a rule of thumb. And then, of course, you use the pulleys to speed the supercharger up or slow it down to match the output of the supercharger to the needs or the parameters you're shooting for on the engine. So it was 213. 218.
Which is similar to the 221, right?
Yeah, right. So the smallest supercharger that I work with, there are probably plenty of other smaller superchargers out there. But the one that's on my Model T and the one that's just over your shoulder there is 142 cubic inches. And so that would work on a 213. You'd want to slow it down a little bit compared to put it on a 290 cubic inch, but that would work. Then the challenge is really just figuring out how to adapt it to an intake manifold and get a pulley that can drive off the crankshaft. And I bet you if you Googled that, though, I bet somebody's done it. And maybe even has some plans that you could use to adapt it. But yeah, you can supercharge really just about any internal combustion engine.
Now, do these come with different length shafts or different ways to, because obviously a V8 is going to be more compact, an inline 6 or 8 is going to be a longer intake manifold, right?
Yes, that's a good question also. And the answer is yes. Um, at least for these that I work on, the shortest shaft, which is this one, input shaft,
Mm-hmm.
is about, around 7 inches long.
Okay.
And the longest one that I work with is that one sitting on the bench right there, which is about 11 inches long. So
Okay.
that's about the range of these. Now,
Uh-huh.
somebody
Mm-hmm.
that's interested in doing this could,
Yeah.
if they know a machinist, they could probably have one whittled out of aluminum and steel and make whatever length they want.
There's a lot of CNC and billet work getting done these days to adapt things, right?
That's right. But I would say that, something like that, 10 inches long, and that supercharger case is about 14. So you're talking about 24 inches long. And, that's about where you'd want it,
That would
really,
be pretty close,
on
yeah.
a six-cylinder,
Yeah.
typical six-cylinder.
Mm-hmm. Okay, good answer.
Yeah, well, it's an answer.
That's good. The next question we have here from someone named Phil is, can you use 8BA valve assembly on earlier Flathead engines?
You certainly can. In fact, I would recommend anybody that's got an earlier Flathead V8 apart, that'd be one of the upgrades I would make to it, is to replace the tuliped two-piece tulip valve, tulip end valve,
Mm-hmm.
and the two-piece valve guides and all of that stuff.
Yeah.
I would replace it with the more modern and, I'd say, easily maintained 8BA style valve train. And I think that's what most people do.
Yeah.
Is that's what they do.
Yeah.
The motor, we've seen it in here a couple times. I'm getting ready to build a 59 AB, which is earlier. And then right above your head are the valve components for that, and it's definitely the same as the ABA.
So there's your answer. Do it. Go for it.
Yeah.
All right. Here is our next question from Albert. He says, how do Ford Flathead overheating problems, which I obviously were as a given, we understand.
Yeah.
How do they compare to other Flatheads of other designs by like Cadillac, Packard, Marmon with their contemporary V8s, 12s, and 16s? They were Flatheads of all kinds.
Yeah. And I'll give you an answer to that. And I'm not familiar with all of those examples that were given. Mm-hmm. Cadillac a little bit. But
Lincoln Zephyr for sure.
A little bit, yeah. So it's, regardless of who's making it, it's primarily a problem with V-style engines. So if we take any, like Flathead 4-cylinder, Flathead 6-cylinder, Flathead 8-cylinder, the exhaust comes, or the intake comes in the side, and the exhaust comes right out the same side of the block. So we don't have this same, long passage of exhaust through the block, mm-hmm. like the Flathead Ford V8 does.
Right.
Lincoln certainly does. Cadillacs, though, the exhaust came out the top.
Oh.
So the intake valves and the exhaust all come in and exit out of the top. So almost like two 4-cylinder, laid together.
Yeah.
So that, I would say Cadillac probably doesn't have that problem as much.
Mm-hmm.
But any design that has the exhaust going through the block is going to be challenged with cooling.
Yeah. And
so when I maybe don't quote this person exactly like you read it, but I think we sort of universally think Flatheads all run hot, and they don't. They don't. They made the Flathead from 32 to 53. People drove them all across the country, through the Rocky Mountains, Route 66, halt, plenty of trucks, plenty of agriculture. And I would say they have a tendency to run hotter.
Yeah.
But they, with the right radiator, the right cooling system, and not tremendously loaded, taxed,
mm-hmm.
They run just fine.
Also, I think just because of time, most people's living memory now, they were old engines already when they first encountered them.
Yeah.
So they've had plenty of time for poor maintenance, being run maybe without the right amount of coolant in them, and different things happening to make the problem worse, I would think.
They are a challenge to keep cool, especially here in Arizona where we are, and mm-hmm. other hot climates. But I would say if we or someone listening out there sort of characterizes the design as flawed or that they all run hot, that's probably a little bit on the outside of the truth. I mean, there
Yeah.
certainly are cases like that. But I probably could cite plenty of small block Chevys I've owned over the years that ran hot no matter what I did to them.
Right.
So anyway,
Yeah.
but the design, because the exhaust through the block, any engine that is designed with that, even ones I don't remember right or know about, are going to be challenged with cooling. They just are.
Think of it as a positive. They warm up faster in the winter.
They do. They do. Yeah.
Okay, so here's the next question. This will be fun. A friend of ours named Dave asks, can you tell us a little bit about the French flathead Ford block? Do you know anything about that?
I do. In fact, I just bought 2 of them about 6 weeks ago.
Okay.
I'm not an expert on the French block, and I'm learning every day. But as I understand it, Ford licensed people all around the world to make their engines, and the French government did.
Mm-hmm.
And there were some cars. The Simca car used a flathead design, a V860 style design motor.
Mm-hmm.
But it's my understanding they made those blocks all the way up until the mid 90s or early 90s, 1990s. So about 40 years passed when Ford quit making them, right?
Wow. What were the applications for those?
Mostly military, so big trucks and things like that.
Uh-huh.
In fact, I saw one here in Phoenix just a few weeks ago that had a flathead in it, and man, it was different than what we're used to seeing. As far as, for example, it was made to run, through rivers and creeks, and so the ignition system was all waterproof. The plug wires ran in conduit, and it was quite the machine. Impressive. But aside from all that, they're very similar to what we're used to. I was curious if they would have metric fasteners or SAE,
Right.
like ours do, and it turns out they're all SAE fasteners. So that's an interesting thing, I thought. They are. I haven't measured or weighed mine, but I hear and read that they weigh about 30 to 40 pounds more, the block, than the American version of the Flathead that they quit making in 1953. So the deck surface is thicker, where the head bolt or studs thread in, they're thicker, which is a good thing.
Okay.
They've revised the cooling. I noticed just with the water pumps off, these blocks are bare that I have. Quite different look from the front of the engine where the water passages.
Oh, really?
You can see back into the block quite a ways, and there just appears to be more area to flow around the exhaust and the cylinders than what I'm used to seeing. There are a couple the ports, intake exhaust ports, are way smaller than what I'm used to, and I think going back to our performance video, what are you designing the engine to make? Making high horsepower with big free flowing ports, or are we trying to make torque at a very low RPM, where the port being small and keeping the velocities high and the mixture moving is the goal. So I think those truck engines were designed to run at very low RPM, make good torque down low. So I saw that. But if you want someday, we'll get one out and we'll just go through it from one end to the other and see what we can learn about it.
All right. Are they primarily based on the 8BA, or they're not the V860, are they? Or
no, it's interesting. It's kind of a cross between the 59 AB style and the ABA. It's a little bit of both. And there's a few of these blocks that are out there floating around that are new old stock. They've never been assembled. And the ones I have are shiny new steel, which is like, that's really great for somebody that likes to build flatheads, just to start with a fresh, never been bored, no rust in it, no cracks in it, no.
So the ones you have, they've been run, but they've never been run.
Never been run, never been assembled.
Oh, wow.
Yeah. So they're out there. One difference, the military, because of the military application, they had a governor, an oil-driven governor to limit the speed of the engine.
Okay.
And that was integrated into the back driver's side of the engine. Remember the 59 style has that bell housing cast in? So right towards the top of that had this big, bulge of cast iron with some oil passages and a place to bolt this governor to. Okay. It's quite ugly, actually. And it gets in the way of the firewall and the transmission tunnel if you try to use it even without the governor. If you just blocked it off,
Oh, I see.
It's so big, it's in the way. The first thing people do is they machine that off the bed. There's still a little bump there, but it's gone on these that I have, which is good.
Interesting. So that was a good question.
Yeah,
Thank
great
you,
question. They're all good
Dave.
questions.
That's really good. William is asking, are the 1932 to 37, we call that Series 1,
Right.
are those flathead V8s considered less desirable? Should they be sleeved?
Maybe more useful for people that are trying to restore an original car.
Mm-hmm.
They're, the early ones, 32 to what do we say, 35, have Babbitt main bearings in them, which are good bearings, but relatively expensive to get replaced and remachined. There aren't that many people that do it, but those that do it are experts at it. We did talk about the limitations of the 21 stud motor on how big you can bore it.
Yep.
Nothing wrong, in my opinion, with sleeving these engines. I have no problem doing it, and never had a problem with it being done.
Okay.
Of course, like any machining operation, has to be done correctly, but done correctly, I think they're fine. In fact, we did talk about Ford at the factory sleeving the blocks straight from the factory.
That's right.
Thin sleeves nonetheless, but yeah, I think it's fine to sleeve the early motors. If you need to save one, like if you have a 32 Ford that you want the original motor in, it's definitely worth using a 32 motor, getting it sleeved if it's needed, and keep it running.
Yeah.
Performance, there's some folks that do nostalgia drag racing, and where the 21 stud is desirable for their class that they run in, or maybe just the look, the period that they're building their car for, and the 21 studs are great for that.
Mm-hmm.
The 36, there's a block right there that has that was the first year for the inserted main bearings.
Yeah.
More modern main bearings, but still the water pumps on the head. So that's kind of a favorite of hot rodders and street rodders. And then 37, of course, starts the transition into the 24 stud and later. But
yeah,
I think if it was me, I would stick, if I was doing high performance stuff, I would start with the 59 style and then the 8BA style as my preference. That's not to say you can't hot rod any of them.
Right.
But those tend to be the ones that parts are out there for, and they're maybe castings are thicker for allow bigger bores and things like that. So that's my personal preference.
Yeah.
But they're all hot roddable, but definitely save the early ones. There's nothing wrong with them. They work fine.
Cool. All right. Well, this is kind of fun. I hadn't remembered this question being in here. It's an interesting kind of way of looking at things regarding the scarcity of the 32 V8 engines, because we talked about how a lot of them got replaced over time and so on. And also, I don't know if they even made as many that first year as they were trying to develop it. I don't think. Yeah,
there weren't very many.
So what would the value comparison be of an original 32 engine and an original, i.e. not reproduction parts, ARDUN engine?
Oh, goodness.
Hey, look at that.
Yeah, well, that's not an original ARDUN.
No, that's not an original.
But so by far, the ARDUN is more valuable today.
Okay.
Let me sort of clarify, though. If we were sitting here 10 years ago, the 32 engines, and I point over here because it's sitting right there, were pretty valuable. When I say pretty valuable, $7,500 to $10,000 maybe if you had one that ran and was complete. And that's because there were still people restoring 32 Fords and trying to make them as original as they could, showing them, competing in judged competitions where originality was important. There are very, very few people anymore that are really restoring for the purpose of showing really any cars anymore. I mean, resto mods, like the current trend with the muscle car era, very few numbers matching cars anymore because it's not as big a deal.
Right.
Some like Corvettes maybe, or maybe Hemi kind of cars, maybe those still matter a lot. But for the most part, people don't seem to care too much about numbers matching as much anymore. Same with the 32 Fords. That motor 10 years ago, $10,000. Today, maybe $2,500. So the value has gone down.
That's changed a lot.
But the original ARDUN stuff has certainly not gone down. If anything, it continues to go up, especially the original stuff.
Yeah.
So the answer from me is the original ARDUN quite a bit more than the 3240.
That'd be the go-to, yeah. Okay. Well, thank you for that question. Very good. Let me see if I can get this next one. Re-21 stud boring. I think what got people's attention is you can't really do much boring. It's not that you can't do any, but
That's right.
you can't do much because of that stud being right at the bottom of the
Right.
cylinder. Someone's suggesting, would a premium fire ring gasket, such as stainless steel, compensate for the low compression and weak head studs in a 21 stud flathead?
Well, maybe just a clarification. I don't think they're weak studs, and I think 21 bolt studs on any four cylinders is plenty.
Yeah.
The modern cars, the LS, and I can't remember exactly, but it's somewhere close to half of that number.
Right.
So the number is not the problem, and the strength. They're 7/16 bolts and 21 of them. So it's not an issue with strength, in my opinion. What is a problem is when you get so close from the cylinder to any of these studs, there's just not room there for an effective seal. No matter how much clamp force there is, there's just not a lot of material there.
Mm-hmm.
And that's not to say they won't seal, but it just limits to how far you can bore a 21 stud. There certainly can be bored. I have. Well, we talked about the 32 being bored 60 over. I have a 37 block that's 21 stud that's bored 60 over.
Okay.
And that seems to work just fine.
Okay.
But we've got this one here is bored over 125 thousandths, and there's still plenty of room as far as the gasket goes. There may not be much, you have to always worry about the cylinder wall, but I think there's plenty of that as well. But you don't have the same limitations.
Right.
But I don't think it's an issue of stud strength. But back to maybe the point, the better the gasket, the better. It doesn't matter if it's been bored or not. I'm a supporter of get the best gasket you can.
Mm-hmm.
And certainly the style that this gentleman or person mentioned is good.
Yeah.
The ARDUN behind you there has the new multi-layer steel gaskets like the modern cars have.
Yeah.
So it has that, which is an excellent gasket.
Excellent.
So I think the better the gasket, the better. Okay,
so now we've got another question. A viewer named Thomas. Now he's getting creative. So here we go.
Good.
This is what we like. We like being creative.
Absolutely.
Okay, so as to the 21 stud, and as a design flaw, we'll put in quotations because of the limitation boring it out. I wonder if one of the single bottom studs could be replaced by two studs at 5 and 7 o'clock of that piston. And of course, you'd have to modify the heads to go with that, of course. That's just a question out there. What would keep you from doing that?
Well, I would say nothing comes to mind that would prevent that, other than maybe how much you're trying to spend to do it. Now, some people that watch your channel, probably very capable machinist, maybe have some very capable machines, and perhaps that could be done.
Mm-hmm.
I don't think I've ever seen it done, but yeah, there's an issue with the block. Probably has places there that you could put those extra bolts, and you could probably plug the one that's being eliminated, the one at the 6 o'clock position.
Mm-hmm.
And as you mentioned, the cylinder heads have to be similarly modified.
Yeah.
And I think where you'd end up with a 24 stud motor. So maybe, and I'm not belittling the comment. I think it's a good question. So I think it's probably technically possible, but does it make any real, I don't want to say sense, that's not the right word I'm trying to, but is it really what somebody would want to do? Or would it be better just to get a 24 stud block where the heads are already set up that way and the block's already set up that way?
Is that about where the studs are on the 24 stud?
Mm-hmm.
Okay. So Thomas, you're kind of on the right track. You're on the track that Ford went to, really.
Yeah, could have been an engineer for Ford in the early days. Yeah.
There you go.
Yeah.
You could do it and be one of the first, if not the first person to ever do it. So that would be another thing to have fun with.
Yeah. Maybe, Barry, if you let me just grab a cylinder head and we'll look at it.
Sure. Let's do that.
Hey, so Barry and Thomas, I just grabbed a 24 stud cylinder head off the shelf, and I think the question was, could you replace the bolt that's sort of problematic? And I know we're looking at the head, but the block's just a mirror version of this, and put a bolt at I think it was 5 and 7 o'clock.
Mm-hmm.
So on the 24 stud motor, they sort of did that. It's probably not precisely at 5 and 7, but instead of a bolt being right here in the middle, like the 21 stud, the 24 stud has one here, just a little bit before 6 o'clock, probably 5:30.
Yeah, right.
And also one at 6:30, which does the same basic thing that Thomas is.
Thomas is on the right track.
He's on the right track. That's right.
Huh. Yeah, that's good to understand that.
Yeah, I think it's a great question. But that's so on a 21 stud, there's 5 studs or bolts along the bottom, and on a 24 stud, there's 8.
Yeah,
and that's because they moved them out.
Yep. Okay. Very good.
Thanks, Thomas.
And I love this guy's name. It's a mechanic somewhere.
Yeah.
There you go.
I know a few guys like that.
Yeah. Okay, on the 21 stud bore again, would dry sleeves with machined fire rings. So we're going to the next level here. Machined fire rings allow for a significant bore size increase on a 21 stud. What do you think of that?
Well, I think we'll run into the same limitation about how close that stud, that I'll call it the 6 o'clock stud on each cylinder, is to the bore. You still have to have room to cut that fire ring and actually lay it in there.
Yeah.
And on a stock bore, I think you could.
Okay.
But as you start to bore, 60 thousandths, trying to go maybe to 100 thousandths, that ledge just gets very, very, very thin.
Yeah.
I have not personally tried it, so maybe somebody has and could weigh in on that.
What is a fire ring?
So my understanding of it, and I've never personally done it, but I've seen it done, is you cut a small groove around the cylinder, in the cylinder top of the block, so around the cylinder, not very deep, but then a little piece of usually copper wire, it gets put into that groove, and then the cylinder head sandwiches that copper groove, or the fire ring, into the, and you have to also cut the similar groove in the cylinder head.
So again, you're sandwiching something in
there, and you still use typically head gaskets as well, and somebody may be better expert than I am. But when we talk about, I think the person that wrote the question, that's what they had in mind, was could you cut that groove around the cylinder and the head and get it to seal better when you have limited head gasket room there. Yeah. And I think you could if there's room.
Yeah. It's just, there's no way around the fact that there's just not much room.
Not much room, no.
But
these ideas, better gasket materials, the fire rings, those are all excellent ways to improve the sealing of a cylinder. And that's our challenge here with this motor. Yeah. Okay.
Would re-sleeving the cylinder gain you more head space so you wouldn't get head gasket blowout?
Yes. The stock bore, 3 1/16, the head gaskets held up fine.
Okay.
They really did. Where you start to get into trouble is when you start to bore the cylinder and you have less and less area for the gasket to work, or even to get one that's designed to work with that size of a cylinder. So yeah, re-sleeving back to standard, that's a solution, a real possible solution.
Okay, good question. That was Carl. Thank you, Carl. Yeah. Now our friend Will. Okay, so this is another variation. These are all good questions, right?
Yeah.
Is it feasible to just remove the bottom studs on the 21 stud and just use a gasket without holes there? Is there enough clamping on that head?
Well, I don't know the answer to that. I would say there's a couple of challenges with doing that. The Flathead has what they call wet studs, meaning that the hole, the threaded hole where the stud or the bolt, depending on what people use, goes right into the water jacket.
Okay.
So if you removed a stud, you'd also have to seal up that hole where the stud was.
Okay.
And that 6 o'clock location, if you look at where the other bolts are around the cylinder, that 6 o'clock stud is, in my opinion, a pretty critical area to have good clamping force, irrespective of the distance between. So I don't know that I would say that that's something that would work, but those are some of the things to think about. Plugging up that hole and then seeing if you could, um, not see if you could, but see if it's realistic that it would seal up with that missing, being that's such a critical location on that cylinder.
Right. Right.
Not something I would suggest trying, really.
Yeah, it'd be an experiment for
I
sure.
probably, if I was faced with that, I think I would just sleeve it like we talked about a minute ago and go back to stock and use the studs just like the engineers in the early days had envisioned.
Right.
Yeah.
Fair enough. Okay, so we have 2 more questions on this general subject.
All right.
So here we go. People are. I admire creativity. It's awesome.
Yeah.
Can a spacer, extra gasket, sleeved cylinders, longer valves or valve stems, I guess, and modified crank and rods extend the cylinder depth in the 21 stud?
So here's the way I interpret that: is some type of the spacer. Maybe it looks like the same shape as the top of the block. It's just maybe I'm going to say it's arbitrarily a ½ inch thick or something. So we have longer or and then put sleeves somehow down in that extend the cylinder up. I don't know that you could extend the valves up, but I think you could probably leave the valves where they are.
Yep.
And then, yeah, different crank rods. But yes, you could increase the displacement. Probably not the most efficient way to do it, and pretty expensive and complicated, but I follow the rationale. Getting the whole thing to seal up both on the water side and the combustion side would be some challenges I could see with that, with going down that road. But it'd be fun to think about, and I bet somebody out there has done something similar to it.
Yeah.
In the day.
Well, sometimes racers do crazy stuff.
Yes.
Even try stuff that may not work, but they'll try stuff.
That's right.
So
that's right.
Pretty cool.
Yeah, I've certainly never done it. I haven't seen it done, but that I follow the logic, and
yeah,
if you overcome some of those obstacles, I guess it's possible.
Yeah. Okay, this last one, and maybe it's my favorite. This is a pretty good one on the 21 stud, because I'm curious to what you're going to say to this.
Well, me too.
How about you offset bore the cylinders further away from the bottom stud into the other part of the cylinder?
Huh. I don't know. What the first thing that came to my mind, and I'm not saying this is right or wrong, but the first thing I thought of was the rod angle. You want the crank and the cylinder to to run essentially perpendicular to one another, and offsetting it seems like that would be a problem, although I can't articulate the problem. When the combustion process, the spark plug sparks and then the cylinder pressure ignites, the angle of that rod has to be such that it can act on the crank and spin it. And if you offset the cylinder a little bit, I'm not sure if it, I think we're talking about offsetting it towards
I'm imagining
the
by what
valve.
he's saying is the piston is closer to the valves.
I think that's
right?
Yeah, to get away from
from that bottom stud.
But what I'm having a trouble kind of thinking in my mind is, so what's the relationship of the crank now? Is the crank coming up this way so that it's offset over here, and now it tries to push the crank the wrong way?
Right.
Because it's not centered. I don't know.
Yeah, or would that change maybe how the timing with the cam works and all?
Well, I'm not saying that. I just wonder if the angle of the connecting rod to the crank pin, if you offset the cylinder, my feeling is that can have a detrimental effect on the engine's ability to even run. But I can't really articulate my thoughts. That's just the first thing that comes to mind. So I don't know the answer, but that's my thought about it. I'm thinking that's probably not a viable option, but I don't know.
Right, and then we don't even know about how much cylinder wall is there if you just offset boring up in one direction only. How far can you go?
That's a good point. I really hadn't thought about it, but yeah, the cylinder wall can probably take probably 50, 60 thousandths in that direction, which would be like 100 thousandths if you took a straight bore.
Sure.
50 thousandths off the side, maybe 60. So not a lot of difference, but back to the kind of my original thought on this whole thing is you can solve all these problems just by sleeving it back to standard, putting stock gaskets on it, put it back together.
Okay. Well, that was a lot of fun going into a what if this, what if that on 21 studs. What I love is all the guys watching that are thinking, well, they're actually thinking. They're like, okay, how can we solve this? And
and like I said at the start, I'm not the expert on all this stuff, but I do appreciate the people that are thinking outside the box and coming up with creative, because it gives me something to think about that I hadn't thought about before. So some of my answers maybe weren't all that complete because I never thought about this before, but I do appreciate the questions, and hopefully my answers might spark some other thoughts of people, and I look forward to getting their feedback on the comments.
Fantastic. Well, Steve, thank you for sitting down with me and answering some of these questions.
I enjoyed it.
You did a lot better job than I would have, so I really appreciate that.
Anytime, Barry.
Okay, and thank you all for sending in your comments, for watching our videos and thinking about this stuff. It adds to our conversation, and I hope you keep doing it. And I hope, Steve, that we can do this again sometime.
I'd love to, Barry. We'll see you next time.
All right, thank you. And we'll see you all again next time on BarryT's Garage.